Okay, so we're going to talk about getting started with pfSense and building your own home router. And this is really ideally for like a budget build or a home build, or you just want to get started with pfSense. You're not sure what to get, what to buy. Now for commercial installs, we buy the genuine Netgate hardware. If we need service level agreements, support, and something that is going to be professionally installed, we're going to go high end. For when you want to build and do some testing and learning, this is a great way to start. Or if you're building your home network or something you have direct access to and support, so you're not worried about troubleshooting it and nothing's mission critical, use motherboards and use cards definitely work well for that. Now let's talk about what parts we have here. This is an Intel quad-core Q2800. Would I highly recommend this? Not really. It's what I had laying around at the office here. So I also get it to prove a point. This is a 10-year-old motherboard and about a 10-year-old processor with it. I don't know the exact release date for this chip. Been around a while. Not highly powerful. Also does not support the AES-NI encryption instructions, but that's only really going to affect VPN performance if you don't have that until version 2.5 of pfSense, which will require that. I know that's down the road at some point. I just didn't have one of those chips laying around here, but you can find those, even like the AMD FX chips support AES, and those have been around for a number of years, so you can find other inexpensive ones. Now, part of the point is, also I want to show you that with a 10-year-old motherboard, you can still route at gigabit. So this will route, even though it has 2 gigs of RAM and a 10-year-old processor, it will do gigabit. Part of the key to that, though, having the right network interface card. Now, there's a lot of network interface cards that are compatible with FreeBSD. I really prefer the Intel. They're kind of a great go-to card that you can just trust compatibility with. Now, this is an Intel Pro 1000 AT quad port, and this was a whole whopping $25 used on eBay. This card's about from 2012, so there's a bunch of them in the market. You can pick these up, like I said, buy it now is $25. You can probably get lucky and buy them for cheaper or buy a few of them. Now, what's nice is they have 4 gigabit ports on here, and they are fully supported in BSD. Now, part of the trick to the way BSD and pfSense and everything work together and how this entire thing is orchestrated, you don't need a lot of processing power for routing because BSD offloads that to the chip. That's why these heat sinks are on here. These chips get a little warm. This card definitely pulls a little bit of juice. But the routing, pfSense orchestrates and tells this how to route. That's why you'll watch, and we'll do this in the demos when we set this up, when we're doing speed tests, you'll see the full gigabit speed going across here, and you'll watch the processor move very little. That's because the chips here are doing that part of it. Now, what do you need a fast processor for? Well, if you want to do advanced intrusion detection and things that require the processor to look at the traffic that's passing and do some analysis on it, for example, running NTOP so you can watch all the traffic routing, or running Suricata, that's where you may want a little bit faster processor. But I will show with this, you can run those tools here without the processor getting way overburdened, and it'll still route reasonably fast. That's going to vary a lot for processor to processor, but I'm just going to give you the idea that yes, you can. But for routing, QoS, and your basics, creating all the firewall rules to keep your network safe and to separate traffic, this works great. Now, a couple things we're going to get in this video was first, how to install pfSense. Pretty straightforward, but I'll still walk you through the process for the first timers here. Then we'll talk about creating WAN, LAN, and a second LAN for maybe all your other things that you want to put on there, and how to create those rules and how to create it so you have a secondary LAN that is a separate network. So maybe those things you don't trust, like you're plugging your Wi-Fi toaster in and things like that to that second LAN. In this demonstration today, we're not going to use any smart switches. I'm assuming that you're maybe a home user or first time and you don't have access to a lot of hardware, which is why we chose some old hardware to build this with, and a standard inexpensive Netgear 8-port gigabit switch as well. It's really nice, and I'm going to do some other videos, and I have done some videos on how to use VLANs and everything else, and those are a lot of fun, and you can buy some expensive hardware for that, but we're going to start with this right here. And then maybe later on I'll do some other videos. But this is the goal is to download pfSense, which I'll leave a link where to get that. Download it, use whatever tool you want to image it to a thumb drive, and we're going to load it on this computer, and I'll walk you through the steps. I just happen to have old hard drive laying around. Yes, this is, in case anyone's running one of those old WD Velociraptor drives. They're kind of cool. They're fast. Now, a lot of people ask, do I need an SSD for pfSense as well? Not really. I mean, they're somewhat expensive. You may as well buy one if you're building one, but do you need a big one? Well, how much do you plan on saving on here for logging information and things like that? If you look at the genuine Netgate hardware, you'll see they frequently don't ship with large hard drives. And the reason why is unless you plan to dump all kinds of logging data to the drive itself, you don't really need a big hard drive. The other thing is, if you're setting up something in a more professional environment, you may have the logging turned on, but you often dump everything to an external logging server. Once again, means you don't need a big hard drive or a lot of write. But if you want to do a bunch of packet capture, and I did a video on troubleshooting with pfSense and how you can do packet capture with this, that does need a place to store all those packets. So then you would want a bigger hard drive. So those are just some of the considerations on there. But for the most part, if you're not doing any packet capture, you go, you know, I don't really care about all that logging. I'm going to keep a couple days with the logs, which don't take a whole lot. I just want it to do routing and security, no problem. So it'll handle that part and a packet filtering and QoS. Those things do not take up a lot of hard drive space. So small hard drives definitely will work. All right, let's get started with actually loading this now. So I'm going to plug all this in, and I'm so budget here, we didn't bother getting a case in. I just don't feel like mounting any of this in a case. So plug in this here. Oh, this is my stand, which is a hard drive box. Got a thermal take power supply sitting here. So first thing you need to do is get into the BIOS of whatever machine and make sure you choose the USB drive as the boot drive. So we're going to go ahead and select that. And this is going to vary, so I'm not going to cover this much with every motherboard you have. But the goal is to get it to boot from the USB that we have on here. You can see our USB blinking away right here. If you have a faster motherboard, this goes a whole lot faster. First thing we're presented with is this. We have to accept the license. Now you can install, if you're recovering, this actually does have a recovery. And the other option too is recover config.xml. If you ever have a pfSense crash that you forgot to back up, which I highly recommend backing up your configuration, it does have the option to try and find the recovery file, which is config.xml. That is where your configuration is stored, and that's all you need. That's like the one file you need to get pfSense set back up the way it was. So do back that up. Install. Default key map, unless you have something custom. Now, auto UFS, manual shell, auto ZFS. ZFS is the newer option they added in the later versions, and definitely go with ZFS. This actually has the option too if you wanted to set up a mirror or RAID array within pfSense, so you want it to run redundantly on a system. You can do that. It does have that option. We only have one drive, so we're just going to go ahead and use the defaults. It also has an option in here if you want to set up encryption. That means you'd have to type a password each time it boots, but if you're ever worried about someone physically taking your machine and exfiltrating the contents of your pfSense config, you know, things like your special VPN rules or anything like that, you can encrypt it, and the only downside is every time you reboot, you physically have to go to the machine to type in the password. Choose the disk. We would be able to select each disk in here. This is the USB that we're booting off of. I'm only going to select this one here. But if you had more drives, you would just press the space bar and select each drive that you want to make part of the array, if that's what you wanted to do. Last chance, we're going to destroy the data on this drive. Yep. And now it loads. Installation is now finished. If you want, there's an option, of course, if you know some more custom things you want to do to it, you can do that here, but we're just going to say no, because we're done installing, and we're going to reboot. And we'll pop out the thumb drive. Now, this is the first part where sometimes things can get confusing. Now, I've actually disabled, so you may notice that there's an onboard network card. I went into BIOS, and this onboard one here is disabled. Then we have these ones here. Now, it's going to vary from card to card, but as you can see on the screen, it says IGB 0 and IGB 1. The assignments on the Intel network cards are either top to bottom or bottom to top. Depends on the card, depends on the configuration, depends on if your machine's on its side, then it's going to be left and right. If it's on its back like this, it's going to be up and down. This sometimes is just a guessing game, but good news is they help you out with this a little bit. So let's set up the interfaces and figure out which one of these is our LAN interface. So the LAN interface is either going to be, because the LAN is assigned IGB1, so it's either going to be this one or this one. It's because it's not one of these is 0, whether it's the top or the bottom, we'll have to guess. But I'm going to plug this into my laptop and we'll start doing the guessing and figuring out which one it is. Well, that got me a link light, but no IP address. And plugging in this one, both got me a link light and an IP address on my system. Now, a couple things you can do here. If you wanted to assign the interfaces differently than they are, I'm going to show you how to do this real quick. You go here to 1 for assign interface. And you notice how it says valid interfaces and which one's up and down. This is a handy way to do this because if you plug it in, this will let you know what the interface assignments are. And as you can see, I only have one of these plugged in, and you can see that's up. So you can build it out that way. You can also start building your VLANs this way in case your internet is provided off of a VLAN ID, so you can set the tags on there. But we're not going to get into all that, but you can do it from this. If you're not sure which one, you don't want to just plug in and guess which one of these it is, you can actually reassign them to be the ones you want them to be, and you can see which ones are plugged in by doing this. So we're just going to cancel out of this and go back here. So once we have that assigned, and I figured out which one is IGB1, which is my LAN, and my laptop now has an IP address, and we're going to log in here in a second. The other thing we have is, let's plug in our WAN. So that's this one here. So now we have a link light, and we'll just show you real quick, just to go in and show you that it's up. So we have both of those up. And after pressing enter and refreshing the screen, we actually see we have an IP address assignment on the LAN. Out of the box, pfSense on the WAN side is set to DHCP. So if you're plugging it into a cable modem or whatever you're plugging it into, you're going to get an IP address provided by whatever device goes on the WAN side. The LAN side, by default, out of the box, is 192.168.11/24. When we walk through the wizard here in a second, it'll let you customize that, but this is the out-of-the-box configuration. The other out-of-the-box configuration we're covering in a second is its admin and pfSense is going to be the default login. Now, someone's going to comment that 192.168.3.118 is a private IP address. That's because this, for demonstration purposes, is running inside of my network, so it was assigned a private IP address. You should get a public IP address if you're plugging this into a bridged cable modem device. By the way, if you want this to work properly, whatever device you're plugging into, if you're running at home, you want to make sure that device is in a bridge mode so you get the public IP address. If you plug this directly in, for example, to a Comcast device, it's going to hand it a private IP address unless that device is in bridge mode. It goes beyond the scope of this talk, but that's the term you're looking for. So a lot of people, what do I need to search for to get this plugged in and set up? Bridge mode, that's the important part. All right, so I opened up Firefox, and I already clicked through the security warning of, this is an insecure connection because it does use a self-signed certificate and SSL right out of the box. Default passwords, admin, and pfSense. Now, if you notice, it lets you know that I logged in. You notice that over here on the pfSense machine itself. And now we're just going to walk through the wizard, which is really straightforward. Next, pfSense, local domain. This is obviously some debate. Pick whatever DNS server you think is the right one. This is where if you want to override the DNS that was assigned by the network interface. You can customize this later. This is just some default options out of the box. And I'm not going to debate which one's the best. That's very subjective. Make your choices. Here, choose your time zone. We're going to choose where I'm at, which is Detroit. Configure WAN interface. Like I said, as you've seen, the default interface is decided by DHCP, but you can statically assign it at this point if that's what you want. We're going to leave it at DHCP. Not because you have to, but because we are for this demo, we are going to turn off this block private networks. And we're doing that because we don't want anything added to blocks. Now, what this does is blocks like your private IP ranges, but because we're using private IP ranges internally for demonstration instead of a public IP range, we're turning it off. Not something you necessarily need to do. This is where you can customize the LAN IP address for purposes of this demonstration. We're going to leave it at 192.168.1, but if you're going to set up VPNs and things like that, a side note is you may want to choose a different address. And the reason for this is if two networks, the one you want to get to and your network, happen to have the same range, you're going to have problems because you suddenly have a competition. If I have 192.168.1.10 as a device I want to get to over a VPN, and my network has something at that same address, you then have to play with the routing to make sure which one of those you actually want to get to when you're connected to the VPN. So you may want to assign something other than this, but that kind of depends. Don't assign it the same as your corporate network that you want to connect to or whatever network, because that would then cause a problem. So this is just a thoughts on assignment. Subnet mask, once again, depends on how many devices. If you're not familiar with CIDR notation, /24 is the same as 255.255.255.0. Next, admin password. Set your password up here. Now, good news is, by default, pfSense does not have external access turned on. So if you do set a weak password, I recommend a good password. It's only accessible inside your network unless you open it up externally, but choose a good password. Then we hit reload. And we're in. And now you can click here to learn about support. You can click here to continue to pfSense Web Configurator. We're going to go ahead and log into the configuration here. Accept the terms and licenses. Yes, you can get global support and everything else. They have community support, global support. They have other support options. You can buy support contracts and things like that with them. So we're going to go ahead and just close that. I will pull up here and add service status. I just like seeing that here so we can see the things that are running. And we can also do traffic graphs if we want. So we can see how much traffic is going across here. Now we only have two interfaces right now. There is an update, I'll load that later, but you just load the updates by clicking here and hit confirm. So we're not gonna worry about that at the moment. Let's get this going through here. Now, a lot of people stop here and this is like, how do I secure everything? How do I lock it all down? Good news. We're going to go to Firewall, Rules. Notice the lack of rules on the WAN. By default, pfSense lets data go out. It does not have any rules opened up for your devices. So kind of out of the box, it's secure. It is not opening ports. It's not letting things in. It's not allowing stuff go on there. Things like UPnP. Those are turned off as well. So right here is your UPnP, and that's all turned off as well. And if you aren't familiar with what UPnP is, it is a method by which devices can request that they open ports to your network. This is obviously a little bit of a security challenge because if that device is on your network and it is asking for ports to be open and your firewall goes, hey, you're on the LAN side, no problem, I'll open it up. Obviously, this has been abused by certain nefarious tools and things like that. So that's just something to think about, and that pfSense does have it off by default. But a question I get a lot is, I got all these gaming systems that want to do that. How do I turn it on? We're going to cover that. We're going to cover how to put that on a separate network. So interfaces, assignments. We have our LAN and WAN. So these are set up, and you can see that the same interface names apply here, IGP0, IGP1. IGP0 is the top interface, and IGP1 is the second one down, as we've seen when we plugged in our network cards. That makes IGP2 and IGP3 the next two interfaces down for setting things up. Okay, we have pfSense, and it's set up and running here. It's on the 192.168.3.118 network, and if you follow along from their videos, you'll realize that my computer is at 192.168.3.9. So we're going to connect to my computer with iperf, and iperf is my handy-dandy go-to tool for testing network speed. Now, there's lies, damn lies, and then benchmarks. I've heard this said many times. This is just a general raw connection to the system. So this is not a in-depth full network speed test where someone will say you got this much jitter, this much buffer bloat. This is just a raw speed test to show you that this is capable of running at gigabit speeds. So we're going to run iperf client 192.168.3.9. Like I said, this is the same network there, so there's no routing in between these devices. They're connected via a switch. So go ahead and here, and we see that we're running at a full, essentially the full bandwidth capable of a gigabit connection. Now something else to note here. So this is running perfectly fine. We got the full transfer rate within reason. There's actually 3 switches in between, so maybe I lost just about 2 or 3% over if I would have plugged in directly, but it's still a gigabit connection. And one of the things I wanted to show is, you notice the CPU usage is still sitting here like at nothing. So here's our big spike of data that we pulled across, but we didn't really do much in CPU usage. And this is what I wanted to talk about with having the network interfaces. They just don't pull a lot of CPU horsepower to do your routing. Now, one of the things you may notice here is the state table sizes. The state table sizes, not many states here because my computer's not doing much over the internet. Now, this is a limitation on an older system, is number of state tables that you can have and the amount of memory it has. And the state table is basically the state of a connection between any computer on the LAN side through the network onto the WAN side. But that being said, this supports enough that even this board here, I could trust putting, a few dozen computers on without a problem. So for your home network, once again, you're not likely to increase this over what this build is. You see we're not using much memory, and we're going to do a couple tests here to try to increase the number of states that we have. For example, I'm going to open up Facebook and a couple other things in the background here. Now, just by opening a couple things, you see immediately we've jumped up from 30 to 430 state tables. So it does require, as you open up a lot of things, a lot of state tables, but we have this maximum of 120,000 available. So that being said, like I said, we're not likely to overrun this router with that. But you do see, obviously, it went up a little bit, just so you know. And then, of course, here's the data spikes that come with running all those things in the background, but that's still not a problem for this to handle. And we'll run the test one more time here and make sure, even with those extra state tables, you can see we're still getting the full there. Now our CPU usage goes up just that little bit. That's pulling full gigabit, where with all the state tables, we managed to peak it out here at 12%. Now we'll run one more test to show you how the routing works, and we'll get into the actual networking side. So here's iperf running to that same address. P100 means parallel 100. So we want to create 100 simultaneous connections, and a T20 is for 20 seconds, just so I don't have to sit here as long and keep pressing it. So this is running away. We're still getting that full speed. You can watch it here, and the CPU now, because of running parallel, we're up to 20%. But once again, we're still pulling full gigabit from that network. So this 10-year-old CPU is able to route at gigabit and pull that much data. Now, obviously, what happens if we assign something? Oh, by the way, as you notice, we're running that in the background here. And while that's running in the background, pfSense is still completely usable. So let me run it again. We'll just run it continuously for 200 seconds, and we'll go ahead and install something here. So we're going to go here to the package manager, available packages, and for those of you wondering, whoops, yes, it's still running in the background. I'm going to close, I don't need this open. So we're still pulling full data right through here, and we're going to go ahead and load Suricata. And this is still running, and this has no problem down here. So it really doesn't tax the system and make it, even while it's doing all this high-end routing. So now we see the CPU usage going up, and I shouldn't have switched away from the screen that the package manager was installing, but it finished anyways. That's not recommended. There we go. All right, Suricata is successfully installed. Services, Suricata. And we'll just turn this on really basic real quick. Now I did just a basic Suricata setup and have it enabled here. I have an entire video that goes a lot more in depth with Suricata if you want to know how to configure it and how to get it all set up. But I just want to show you that it is running on this system. And one thing we're going to comment here is watch the CPU usage now that we're running Suricata. Because Suricata is inspecting that traffic, this went up from like 20% to 46%. So it is still able to run this. It is still able to run Suricata. We have not completely maxed out this system, but I will, this is where you're going to see a little bit of a taxing on the processor, but you can run it. So once again, for a home lab, this setup works really well. And the same thing if we want to enable NTOP, this would tax a little bit more on the CPU, but once again, you can do that. So even with Suricata running, like I said, we're not completely maxed out this system. All right, let's go on to actually getting some other things set up. And I had mentioned setting up. A lot of people go, okay, I want to separate my computer versus the rest of the insecure devices and things that get plugged in. And we're not doing this with VLANs. Like I said, for this demonstration, we're going to set up another network port, and we're going to expect that you have a different switch that plugs into than the one that your LAN's plugged into. So this is a 2-switch setup. So we're going to go over here. I go here to Interfaces, Assignments, and we're going to pick just the next one down, IGB2. Click Add, and it called it Opt1. I'm going to hit Save here. And we're going to click on Opt1, Enable, Crap Network. So here's our crap network. This is where all the junk goes, all the insecure devices go, the IoTs, and all that fun stuff. Configuration type, static. Now, this is where some people might make a mistake. Don't put in the same as you had for your LAN. So if you did this 1.1, you would end up with a problem of you wouldn't be able to route between them. So you want to assign it separately. We're going to go 30.1. I'm going to make this a /24. And we're going to click Save. And we're going to apply. Okay, for the rest of this video, I've now got this set up with a crap network, and I'm recording it from my office externally from the outside IP address. Now, what I did to enable that, just because I don't want to skip anything, this is 192.168.3.118, which is the external interface of our pfSense right here. And we go to Firewall, Rules, WAN, and all I'm doing is opening up port 443 so I can access it from the WAN side. We have our network built. We have our interface, our crap network. We have it statically assigned. Now there's a couple more steps we need to do. First step is services, DHCP server. For every extra interface you add, whether it's a physical interface or a VLAN interface, you get another tab here, the DHCP server. So we're going to go over here to crap network. Go ahead and enable DHCP interface on crap network. And you can choose the ranges, just like you can with any of the other DHCP, or create a series of ranges, pools as they're called. If you need to do that, we're just going to do the basic and just enable DHCP. Save. All right, so now we have that. Next step is going over here to Rules, Crap Network. Now there's no rules, which means by default, this network does no routing. So anything you plugged into it, it will get an IP address, but it can't go anywhere until there's a rule. Like I said before, pfSense errs on the side of caution. When you're loading it, it's going to create rules for LAN, but none for WAN, and it's going to create for each subsequent network you create, whether it's a physical network or a VLAN interface, and you get another tab here in the firewall rules. There are no rules created by default for them, which is good because that means by default they won't start routing traffic or network until you create the rules to do so. So first thing we're going to do is just create kind of a wide open rule, and we'll call this one wide open. And what we're doing is we're allowing action pass interface, the trap network, address family, and protocol any. By default, it does TCP. And some people will sometimes get stuck on this because they'll let it at the default TCP. Well, that means all these other things don't work. So make sure you change it to protocol any, or you'll only be able to run TCP protocols through this network. Now, here we go. This network is ready to go with wide open. It can go anywhere it wants. Apply changes. And I have a computer on the crap network. So this is our studio computer. It's on that network. And here it has the gateway as 192.168.1, and it's 30.100. I got the first IP in that range. I have my laptop still turned on, and I can ping it. So this can get to the laptop. Let's go over here and ping google.com, and I can get out to the internet and ping Google. But this isn't exactly what we want. Obviously, we want the crap network to not mess with our regular LAN. So let's go ahead and move this out of the way. And like I said, this is a wide open rule. So we're going to go ahead and edit this rule. Now, this is a really simple way to match this. We're going to say LAN net invert match. So what we're doing here, by adding this piece here, anywhere but LAN. So the traffic comes in, it's allowed to pass, comes in on a crap network. It's allowed to go out, which actually we should filter this for coming from the crap network. So coming out of the crap net cannot go here. It's an inverted match. So that means I can go out to the internet, but if its destination is a LAN net, then it won't work. Now, if you have a series of networks on there and you want one network that you want to be only the internet but not any local networks, you can create an alias so you don't have to create too many rules for grouping all those networks together. I watched my alias video if you know how to do that. But in short, for your home network, maybe you want one thing that you stick all the crap on and the other one's your LAN. So now we're going to do invert match, and we're going to hit save here. And you see how it does here in the rules. So we have the port, exclamation port LAN, which means do not go to LAN. And now we're going to do the same thing and bring it over here and ping. I can ping Google, but I can't ping .100 anymore. So it no longer can get to things on the LAN network. It's that simple to put the block in. So there's only one rule, and that rule allows it to get out to the internet, but doesn't allow it to go anywhere else. Now you can get more advanced and move things around and play with this. This is the one that gets you started to create a network that is limited in the fact that it can't get to your other things on your LAN, your important things on there, and things on the crap network are separate. Next thing I mentioned was the UPnP. So we're going to go over here to Services, UPnP, choose Crap Network, choose Allow these things or whichever ones you need. So we're going to enable UPnP port packing, NetPnP. We're going to turn all these, and we're only going to enable it for this interface. And we're going to hit Save. Now what this does is allow those devices on that network, so all your Wi-Fi toasters and refrigerators and random things you want to plug into that network are now attached to the crap network, and they are allowed to use UPnP on that network without risking opening ports up on your LAN side. So it's still going to open up by default. The external interface is WAN. So it still opens up the firewall and lands on devices in there, but now you have narrowed them down. And this is also handy for things like when you want to do any traffic filtering or figure out what devices are doing, you can go look at that network separately and have all your other things not interfering with them on there because it's one network. So this should get you started on how to start building out your network and getting things set up so they're separated, so you have a network where you put everything else that isn't important to you on your LAN. This, like I said, is a common use for pfSense. And like I said, kind of the point of this video was to show you that it does not take a lot of hardware to make this happen. So we're able to route at those gigabit speeds, we're able to do things really fast, and we're able to separate the networks. So we have two of them, and all you need now is a switch plugged into LAN, and this is where your protected LAN devices are, and a switch plugged into crap network, and that's where you plug in all the other devices. Okay, one thing to show you here on the last note will be that yes, it can route at gigabit speed. This is on the crap network. It's that same machine running iperf, just like we did before, just like we did on my laptop earlier. So yes, it has full gigabit access. It's plugged into the switch, but maybe that's something you really want to limit is how much bandwidth the crap network gets. So we're going to go ahead and see that this ran at 948 here and move this out of the way. Go to Firewall, Traffic Shaper. Now you can run the wizard, which is great. You can build all kinds of queues, and this has a lot of fine tuning things in there, but we're just gonna cover something really simple, really quick. So we're gonna create a couple limiters just to limit the speed of it. So we need a limit in, and we're gonna set the bandwidth at 5 megabits. And hit save. Now you can tweak it and play with all these other things and create nested limiters. We're not going to really cover all of that. So here's our limit in, and we can call it whatever we want. We're going to call this one limit in. And we're going to make another one. Limit out. And you'll see why we need two of them just in a second here. And this one, same thing. We're going to say 5 megabit. Now it also has a scheduling option. There's a schedule built in pfSense, so you can say limit like after a certain time. We're not going to get into all those little details. So we'll save. Now we've created limit in, limit out, and they're both set to 5. And we're going to apply the changes. Then we're going to firewall, rules. Go to our crap network rule. Go here. Now I want to show something real quick. You notice how it just says IPv4 crap network. As long as it doesn't go to LANnet, it's allowed to do anywhere but LAN. So there's our network. We're going to edit this, scroll down, display advanced, the in, the out. So here's our pipe limits. So this is down towards the bottom when you hit display advanced. And there's obviously a lot of more stuff you can do here, tagging and sorting. It's an amazing the amount of details you can get into here. But the short is the in and out pipe is the limiters. And we're going to hit save. We're going to hit apply. Now this little gear got added. And if I notice how I mouse over in a gear, it pops up and tells me. So what that's doing is advanced settings, limiter in, limiter out. Tells me that a limiter's been applied. So any of the advanced settings, add this little gear so you know that there's more settings to this network than just the rules that are being displayed here. It has a more advanced setup. Now let's go over here and do our test again. So here's the test. It was 948. Let's see what it should be now. And we're limited. So now this network doesn't get gigabit. It can only have a maximum bandwidth of that. So that's an easy way to do that, just to say that network only gets this much bandwidth, because how much bandwidth does a toaster on the network really need? Probably not a lot. So this is a way to like filter that down and say these things only get that much, or maybe you want to set it on a schedule and the traffic goes down over time at whatever time you predefine. So that's it for getting started with pfSense. Hopefully this was helpful and get you playing with this firewall. It's amazing. I mean, this is an enterprise level tool that you can just download and using your home network. It's a great way to learn networking and advanced networking and firewalling and all the other fun stuff. And this, like I said, I've got a lot of other videos if you want to go more in depth, or you want to look at any particular things like, how Saracata works or some of the other services we've talked about. Thanks for watching. If you like this video, go ahead and click the thumbs up. Leave us some feedback below to let us know any details, what you like and didn't like as well, because we love hearing the feedback. Or if you just want to say thanks, leave a comment. If you want to be notified of new videos as they come out, go ahead and hit the subscribe and the bell icon. That lets YouTube know that you're interested in notifications. Hopefully they send them, as we've learned with YouTube. Anyways, if you want to contract us for consulting services, you go ahead and hit lawrencesystems.com, and you can reach out to us for all the projects that we can do and help you. We work with a lot of small businesses, IT companies, even some large companies, and you can farm different work out to us or just hire us as a consultant to help design your network. Also, if you want to help the channel in other ways, we have a Patreon. We have affiliate links. You'll find them in the description. You'll also find recommendations to other affiliate links and things you can sign up for on lawrencesystems.com. Once again, thanks for watching, and I'll see you in the next video.